this is the board where the workers decide what they're going to be working on for today. This is a automatic solder stencil machine, correct?
Yeah.
This is a circuit board. It goes in, it'll be a wearable. It goes in here, and you can see liquid solder paste is put onto the board and stenciled across. I'm not sure if we can see in there.
This is really fun.
That's what's happening. It comes out on this little conveyor belt over here. Goes through. And it goes here. You can see that there's solder paste on each of the pads. Now it goes into this machine, which is a pick and place machine. And what the pick and place machine does is it takes parts from these spools of components. You can see these are teeny tiny little resistors, capacitors, other components. They're fed into this machine, and this head picks them up and places them down on the board.
Put this together fast.
So it places them, and then it'll be ready to go into the...
It's so random, too. We were just hanging out, and we're like, we should make a video about this. That's why it's so crazy with all the wires and the headphones, because we were just like, what can we do with what we have?
So once the solder is squeegeed onto the board, the components are sitting on top of it.
Oh, I texted him. He's going to be watching.
Okay.
Our dude's chat is here.
That makes the components actually stick to the board. Behind me,
I think Marcelo might be watching right now.
This is actually where they keep all the spools of components that go into the pick and place. Then behind all of that is where the stencils, right? So the stencil is what they actually put on the, when it's time to put the solder paste on in that other machine over there. They put the stencil in the machine, and it's basically just a bunch of laser cut holes, and so they just squeegee solder paste over it, and then remove the stencil, and then that's how they make the perfect little square of solder paste for the component to be put down on. So, comes out this side over here.
This factory this is in like Shili or something.
You see a completed board right here. They're going to go into this conveyor belt right here, and the board comes through this long oven. It's fed through on a conveyor belt, and there are many different heating zones. Instead of just having an oven that like changes the temperature really fast, because that's harder, you just have a really long oven with many different temperature zones that the board goes through, and it cooks it as it goes through. So now we come this way. The boards come through the reflow oven, and they come out on the other side. I don't know if there's a board coming out right now. Can't see anything. It's basically the same thing as a pizza oven. So as you can see here, we have some completed boards. Oh, DIP components, yes. Her name is Continously, and she's putting on DIP components. Awesome. How many components does she do in one day? Like, are we talking like hundreds, thousands, maybe 1,000 components in one day? Okay, so these components are different than components that were placed by the pick and place machine. The pick and place machine only does the surface mount components, the flat surface ones. So these are parts that actually have pins that go all the way through the board. So this is through-hole soldering, correct? So it's very, very hot. So you can see.
See, that's what they had before they had that selective. Selective wave soldering.
Components are placed on this.
This is actually a machine that just has like a continuous wave of.
And then he's going to dip it into this pot of molten solder. It's going to suck the solder
passes
up
it over the top, and it washes up over the top. And look at that, that's just all melted solder right there. Yeah, and they kind of just like put it in there because the solder will only wet other metal components. It doesn't stick to the fiberglass. It doesn't stick to the solder vents.
We get sound of that? Sizzle?
Yeah, but now they have that computer controlled one that like really precisely goes up. So it doesn't take as much material.
So
and
after
also
soldering,
this
comes to these are cleaning machines right here.
Fumes.
And so we put boards down in there, and it just generally cleans them off before we move into the next step of the process. So issue or quality check comes next after cleaning. We can set up an assembly line.
One day I want to get my own set of this tubing.
So there's some things you can't do.
I think it'd be fun to make some furniture out of this.
Right. So they're
lean-to.
Exactly. So you can see. You can see here, if that's okay.
What? Yeah.
It's going through putting these things in solder by hand. So you see, like, this component needs to come in from the other side of the board, but there's already a plastic piece there, so we can't
that'd be cool, right?
The solder dipping part. Like on the previous machine where they would put the filter components in and just dip it in, you can't do that anymore because it would melt the plastic piece. So if you have to have parts that come through on different sides of the board, you have to do part of it by hand. And that's what these guys are doing.
So your choice of where you put the parts of the board is really
So it's always kind of a game to figure out like what's more cost effective. Do you want to program a machine to do the different parts, or do you want to have a person do it?
When you're designing something,
It's really hard to make machines that are better at doing stuff than people
really
are.
make your life easier if you take that into account at the beginning of the design process.
Especially in the
production process. You can try to automate it as much as possible, or have an idea of how long it's going to take to do all the different steps of the process. So now we're cutting pins.
Yeah.
And that's just it's exactly what it sounds like. Cutting pins. Cutting pins is exactly what it sounds like. Oh, look what it is over here. Let's see what it is over here.
Marcelo.
So these are the actual light bands that are going to be used at
So
the
this is the thing, remember when we did
went to the oven.
the light bands,
The last bit that we have to do is put these actual battery clips onto the board.
We had
and solder them
Seed
on by hand.
Studio made
So now we have
a
to
lot
solder
of
the
them
battery
in
sockets on
China,
it.
and then at the pop-up factory we made the last like 200 or 300 pieces using all the desktop stuff.
So now we're actually testing. Oh, this is the test chip that we set up yesterday.
Oh, that's cool.
One really important thing when you're thinking about designing
So
something
Eric,
is,
did you hear about that whole like?
what's it
We
gonna be,
had
how do
so
you
Seed made the
piece
circuit
parts on the
boards,
other end,
and then
how
we
to
had
test it.
the
If you
enclosures
wanna
made
make
with
something
proto
and have
labs,
it
and then we went to San
manufactured in stainless,
Francisco,
like you're just going to
and
try
O'Reilly
push a
let
button,
us
have it
use their
happen,
office in the O'Reilly
People have to
Alphatech
work on it.
Ventures
There's a whole
office.
process that has to get done.
We
You have to
hired
teach
some
someone else
people
how to
off
make it.
Craigslist
So a very important thing to think about
and
is
took
having
over
an
the
entire
boardroom
test
of their
process
venture
that people
capital
will
office.
know that
We didn't tell them. We didn't tell them. They just said, "Oh yeah, you can use our boardroom to assemble stuff." And we're like, "Yeah, cool." And then we like went on Craigslist and got a bunch of people from Craigslist to do. We set up a line like in their VC
So whenever
office.
he puts a board
We didn't
into
tell them
program
until later. I don't know if we told them. They might just now be
and you
figuring it out.
board,
But it's like
you
this.
get some
Yeah, there's
sort of
pictures.
radio,
There's
and then turn on the seats.
yeah, exactly.
The soft device.
But we took some lessons from how things are done here, but just like finding some, because we put the ad on Craigslist and some people were like, I have no experience with electronics, and we said, well, do you make jewelry at home? Do you do small things? Like we can show you how to do it. It's the same skills. You don't have to have an engineering degree. Like you can just show up and we'll show you what to do and give you some money.
So we need to think about those things.
Yeah, that's why it's better to do that.
To figure out a testing process that would be fast enough for each board, that doing all the boards that we're making wasn't going to take forever. So we had to think about what the procedure would be to make it so we could find out if it's actually going to work, but not take a ridiculous amount of time because you don't have time to be like, oh, let's try this firmware, let's try that other firmware.
I love that thing on my face.
Is it going to work? Is it not? We have to think about the test routine that's going to make sure that we know.
Yeah, that all the components are working.
Yeah. Issuer quality control check happens next. Hello.
My friends are saying, are there 2 audio channels on there for you guys? Cut one of the audios off, it's hard to hear it.
Materials. And the directions. Right. That's what she's in charge
maybe
of
we
making sure
should.
that everything's done according to
Okay.
the specification. That's the entire process for the PCBA means assembled PCB, right? PCB is. Yes, I think we finished. All right. Thank you guys.
We're basically together all the components for the first time. So if something doesn't work now, it's the timer and I'm finding out. Let's see. Doesn't work. What do you got there? Sounds like a snap. Yeah, it works.
There it is. Solid con.
Yeah, wow.
And we're back.
And I think the live streaming is on. Welcome back, David.
Hello.
And hi guys, welcome back to our live streaming. Which episode was it? So making the next gadget, coming back to the factory. And today is a very special session and we have some very special arrangement. We have David who has been making the video from 9 years ago. And he has been traveling back to Shenzhen with his parents, which means other David.
David from the other timeline.
Yes, the David from the other timeline. And David's mom, Marcelo. And we're going to usher you to the factory after 9 years later. And happy to answer any of David's questions. And also whoever is in front of the live streaming, please let us know if you have any question or any inquiries, we would like to explain everything in detail.
Jump in the chat. We're going to do a walkthrough of the facility, and then we'll stop and do a chat and answer questions from the chat room after we do the walkthrough.
But this is very much like we have so many customers coming to Shenzhen to visit the factories, actually sometimes to audit the factory. This is very much like a remote audit for all of you, so feel free to ask your questions. I think before that, let me give you some brief introduction of the operation here. Okay?
All right. Let's hit it.
So this has been like this forever. We call it Agile Manufacturing Center because for a lot of hardware, you need to scale them up in a very easy way. But most of the factories are ready for mass productions. What we are doing today is we look at all the prototypes. We call them 0.1, which is just to put all the open source hardware together. It's working. But you need to upgrade it to engineering samples. You make a few pieces to prove it's working, to make sure it's like complying to all the manufacturing standards or procedures. And here we do a lot of from 10 to 1,000 pieces to really scale them and to make sure you can answer to your Kickstarter campaigns, to do the pre-orderings, then move on to manufacturing larger scales. And we maintain the similar size like you see 9 years ago.
Yeah.
But now it has been so well connected to all the supply chains around this area. And it's becoming an aggregator of all sorts. So if you look at the hardware, a device, stitching everything together, there are so many things you need to coordinate. It's like your chef. You have to source ingredients from all over the world. Supply chain, and you need to ship them.
I think that's something that's really special about the way that factories in Shenzhen works is that everything is so close together.
Yep.
So you can take a facility like the Seed Agile Manufacturing Center and plop it in the middle of everything, and then you can put your tentacles out and gather the components from here, and you can have a factory make the injection molded stuff, and then you can bring it into one location and check everything and put it together, and then start making your production, make 10 pieces, make 1,000 pieces, and then start spinning everything up.
So we have been, like versus 9 years ago, our manufacturing has been scaled for many times, but we maintain this space about the same size.
Yeah. Because
we have a lot of failures. We have a lot of errors, mistakes that have been happening inside our facility that we can respond to that easily. Right. So the Agile manufacturer is still here, but very well upgraded. We still have the process all the way from ordering to preparing SMT to assembly and test, and also to do the final examinations. We have a new thing, a big new thing here is about the wind tunnel laboratory.
Wind tunnel.
Wind tunnels. We have to build one because there's no such thing in Shenzhen. And this is everything we happen in the Agile Manufacturing Center. Okay, should we start the
Let's check it
tour?
out. Where do you want to go? Elevator?
Okay. Welcome. So these are some of the manufacturing we've done, some of the components. You will see it's full of all kinds of things, from heatsink and chipsets and mechanical parts. So it's also a test about if we have a signal inside the elevator.
Yeah, hopefully we have a signal inside the elevator.
Yeah. And also please meet Sasha Wu, our factory manager, who is behind all this to make this so clean and well organized and efficient.
It's like when you're going up the roller coaster.
Yeah.
At the beginning of the ride, yeah.
Yeah, it's good cue to see what's exciting.
Here we are.
Yep. Oh no, not this one.
Oh, different floor.
Because we are sharing the elevators with other manufacturing floors, what do they manufacture? Sometimes you find your suppliers just your neighbors.
Yeah, exactly.
How many floors are there?
There are 5 floors, but there are like about 24 buildings in this neighborhood. And there are like hundreds of industrial parks like this.
I always think it's fun when I'm like looking on Taobao and looking at something. I'm like, where are these people? I need to have a meeting with them. And you look, and it's like, oh, they're right down the street.
Exactly.
Oh yeah, we'll just go there.
So I mean, you're moving around with all the metros, motorbikes, and to check out factories. So David has been staying in Shenzhen for how many?
I've been coming to Shenzhen maybe once a year for about 10 or 11 years now.
Okay.
Working on different products.
So you keep the passion going on and keep coming back, and that's not easy.
It's always
And brought the parents.
Now they know what I've been talking
That's
about
David.
this whole time.
Yeah. Okay, welcome. And we have very humble entrance, and we need to change our clothes. We need to transform into factory visitors.
Yeah, okay, I gotta change my microphone.
And we keep this color pink.
Yeah.
Because it's like you give the birth to a child in the hospital.
Yes. Thank you. Oh, this one is.
We don't manufacture very strict clean room stuff, but you still need to maintain the basic for SMT.
Yeah. Okay, is this an okay place for the microphone?
Yep.
Thank you.
Everything okay for the live stream? Yeah. The bandwidth network is working? Yeah. Okay. I think it's much better than Mexico. Last time we tried with this and there's no sound for quite a while.
I always like to have jobs where you get to wear special clothes.
You should make more like cybernetic clothes.
Yeah. Well, that red coat that I have was inspired by a factory operator jacket.
Okay, really? You
Yeah.
customize that jacket?
Yeah. Totally
Okay.
custom.
You're really hacking into the supply chain of Shenzhen.
So I wanted it to be like factory operator jacket, but make it like.
So you just hack one factory per visit.
Yeah.
You have your KPI going on. So we're going to start with our incoming materials.
Incoming materials.
Okay, here we go. It's okay.
And we have to touch
We have to do the testing to dissipate all the tactics.
Thank you. There you go. This is for your wrist to make sure that it's bro anti-static. Put it on your wrist to get
Do
rid
you
of
have
any
any
static
questions
electricity
on the
you
channel
have.
room? While waiting, we can answer to that. Okay.
And then, all right, now we have to touch this thing. Get rid of any extra charges that you might have on you.
Yeah.
Like this guy.
To get rid of your extra electrons on it.
Yeah, just touch it once. Yeah.
Yeah, so it's much cooler inside. So this is our incoming materials. Whenever we collect the material from all over the Bay Area or other like regions, we ship them here. We do the sorting, we do the inspection to make sure all the components, they're okay. But depending on the components, like some chips, some components, they are very okay by default if they are not tapped. And also we have some mechanic parts that requires extra inspection because you need to make sure they are all aligned to some standards, and it's usually difficult to maintain. But we don't have time to do very deep like analysis of everything. So we try to maintain a balance between efficiency and the quality.
Right.
And you can see the processes here. Like whenever we receive the components, we do send it to the submission here for inspections, and the quality team, we call it IQC, incoming quality check. And if it's finished, we'll go into that little door and put onto the shelf. Right. But we don't have a huge warehouse here. Whatever you see, the material, they are very much like for a buffer. We collect them, and to sort them, then we either manufacture inside our facility in Agile Manufacturing Center, we send it to other manufacturer sites and other contract manufacturers.
Right. So you bring the components here and then check some of them to make sure everything's good. And it depends. You said sometimes if it's something made with the open parts library and you know that it's good, you don't have to check every single thing. But if it's like something super duper duper special, then you can define a test protocol to make sure that those parts are just right.
Exactly. We try to categorize them so most of the products can be finished with less hardware. Most of the time we are waiting for the materials or checking it or talk to suppliers back and forth to make sure that falls into your centers.
Right.
Okay.
Should we shoot landscape?
Landscape?
The camera's vertical. Should we go?
Can we go this way?
Oh, it already.
Okay.
Oh, okay.
Okay.
Right. Well,
don't worry.
That's how people shoot things in the future anyway. I don't really understand why, but that's the format that everyone uses.
Okay. So you see they will do the counting, the checking, and that's a full quality team doing that.
Yeah, see, she's looking through them. checking the number of components, making sure that everything's there, making sure that every single thing on this. So the component, can I pick this up?
Yeah, please.
So the components, when they come on these spools. It's almost like a film reel. You see, it has these little, even has little sprocket holes, like a video, like a film. And so each of these has a little part inside of each one, and later on we'll see that how it gets loaded into a machine and then put onto an actual circuit board. But this is how things come from the suppliers.
Because for small batch manufacturers, sometimes we cannot buy the full reel. It comes into the partial reels, and we need to count, make sure the quantity is okay, and we look at the data code, make sure it's within the range.
Yeah, partial reels. So it's interesting. So the thing that Seed Studio is good at is making things in quantities of 1 piece to 1,000 pieces. You know, most big manufacturing places like Foxconn or whoever that are like nation state size factories that are making hundreds of thousands or millions of things can buy all these full reels and design a machine that does everything automatically. But when you're working at quantities of several hundred to several thousand, it's a little bit harder because you can't design a custom machine for everything. So you have to, the game is to figure out what you want to have be done by machine, what you want to have done by hand by people, and if you get partial spools of things, how to make sure everything is just right. So it's kind of this hybrid approach.
Exactly. So I think during the main challenge we have is how do we fight with this efficiencies on small quantities.
Right.
Yeah.
Yep.
Cool. And we have some, this is new, we have some ME system to monitor all the incoming materials, benches, working nodes, the thresholds, and the environment, because we do a lot of environmental sensors.
Right.
Come in, please.
Environmental sensors.
So you are familiar with this already. We have the carts. Each cart is for batch of manufacturing. And we put everything inside from the documents to the components.
This is 1 cart per product.
1 cart per product.
So you have all the documents for everything. You have the components for it. You've got everything you need for.
Exactly.
This is how it keeps everything organized.
And this will be moving like a line all the way through the manufacturing.
Yeah.
So after you manufacture, you change the containers to like hold all these finished products or the in progress things.
Right.
Yeah. So, like we were talking about the partial components, very important is we maintain this part efficient. Whenever they checking from that area, we'll put the most used components here, and there are so many components be shared between different projects. I think that's the most challenging part. For mass production, you dedicate all components for one product. You buy them for this lot
You
only.
take an entire building.
But we try to share it. We try to share
Because you guys
all
make
the
so many
processes.
different. How many different products are you making at any one time usually?
Well, in any given time is from it can be from 20 to 50.
Yeah, so you
ongoing.
have to have all the components for each one of those things organized and put together.
Exactly. What I mean is just the inside Agile Manufacturing Center.
Yeah.
And after they have the mostly commonly used components, they assemble here. They kitting them here with a PDA. They scan all the barcodes on the reels to make it. It's like a checking process. Make sure the quantity, make sure the types is ready. Then they come up with a barcode. So it's our own internal systems. You will see that it has been matching with all the pick and place machine and other procedures.
Marcelo says, make sure to say hello to Eric. Seed saved our lives many times. Parts in the US, and I had my design already, and then when I came to China, it was really hard to make because the Chinese suppliers had different access into the supply chain than I did, and so I had to redesign everything to use parts that they could use. So one thing that I really like about what Seed does is they have what they call the open parts library, which is a list of all the resistors and capacitors and components and stuff that they know how to get really easily that you can access online. And then if you use that in your designs, then when the design comes here, they already have it. And then they know already how to put it in the machines, and it makes the whole process of spinning it up a whole lot easier.
We're trying to redefine DFM. So for Ample, design for manufacturer is they try to care for the factory, so it's easier to manufacture.
Yeah.
But for a lot of startups or even for ourselves, we want to design from manufacturer. We look at what's existing procedures are. We look at what's existing components are. So we can share the resources or the procedures, heavy liftings together.
Right.
And because we are doing open source hardware, And people starting from open source hardware modules or gadgets to build their own. And most of the time, we just need to customize the PCB, the enclosures, and all the components are already here.
Yeah.
So that's a big saver for small benches.
Mm-hmm. Remix culture.
Sorry?
Remix.
Remix, yes.
Remix.
Yes. Cocktails.
Sometimes you can find something that somebody else has made that's pretty close to what you want to make, and then you can maybe take that design if it's open source and make some changes. Yep, and then you don't have to start from zero all over again.
Exactly.
So sharing information, sharing ideas, and sharing supply chain makes everything work a lot better.
Exactly. So,
Well, I have a question.
yeah, please.
So, everything in here, they checked in?
Yep.
Wow.
So there will be two check-in. Firstly, the check-in from the incoming materials.
Okay.
They will be put into the inventory and categorize, index them. The second check-in is whenever the manufacturing order come in. They will have a bill of materials, what kind of components, how many, and they will use a PDA system to guide them through the shelf and put them into the cart, and they will be counting and put into the box for the next level.
You're saying PDA system?
Yep.
Okay, yeah, these little.
Where is our
So
PDA?
this is your own
System.
Yeah.
See, he's got this PDA right there that they use that they can scan and check everything in, and it's got organization per.
Yep.
Oh, I see.
And then he prints a little sticker and puts it on, and then he keeps all the ingredients together.
There's a Seed Studio sticker.
Yeah.
Yeah, but with the
Yeah.
barcode.
You will
and
you'll
with
see
the
on each
identifier.
of the reels you have many stickers.
See.
It means whoever has been processing that will apply a new layer of paper.
Cool.
It's not sustainable yet, but it's very efficient.
Yeah.
Okay, so this four shelves about the current components we are having, and we stock them for a little while. But from mechanic part is taking the most area of this warehouse, because mechanic parts usually you need some customizations.
Yeah.
And you cannot just customizing for a few units.
And they're bigger than electronic
They're
parts.
bigger. They are more difficult to set up.
Mm-hmm.
So we stock more of those,
Yeah.
and we try to manufacture some for economic scale, then share between different projects.
We got connectors.
Connectors, screws.
Yeah, a lot of screws. So many screws.
Because the SMT or the surface mount components are very easy to standardize, but this part, there's a real magic of the manufacturing system in Shenzhen. You can get everything made, you can customize, and with 3D printer, I think this has been changing.
Yeah.
Okay. So maybe I can try to do some navigation here. We are inside the main hall of linking the warehouse and the manufacturing floors. So we are going from towards the manufacturing floor.
Now we'll go to where the magic happens.
Yeah. So you remember the Silicon? We have the pop-up factory.
Yes.
And that's the smallest unit for Agile manufacturing. And we do it here as a start. And we bring it to San Francisco for a few years.
Yeah. Shout out to Mong Mong.
Yeah. You still remember them. And there's Danny. Danny was back to Shenzhen. I was sending the link to Danny, and he might be watching it.
Right.
So this is cell 0.
This is 0 room.
Yeah, cell manufacturing is different from product lines. It was a very, popular because of Dell. Mm-hmm. Whenever Dell wants to assemble some computers, they have, Dell computer. Mm-hmm. The technicians will be assembling everything in one stand.
Right.
So they are more sophisticated, but it's very easy for him to be answering to different demands in small scale.
Yes.
And we are borrowing that idea and put it into our manufacturing.
Yeah.
So
what they're going to do, check this out.
So each of the technicians here, they are like the super workers. They are not only just repeating the orders.
Get close up here.
Yeah.
Sorry, it's happening, so we have to see it.
You want to hold the camera yourself?
Oh, maybe. I think he's got it. Yeah. So they have a machine that can do this later, but when we're just doing a single board, you start out by doing everything by hand. So what this is a solder paste stencil. So they take the board and they put it under there, and then they stencil the solder paste on, and then it puts a perfect little dot of solder paste on every single board pad. And then components will be placed, and then it'll be put into the oven to solder. So what's cool about this room is that it has the capacity for doing solder stenciling. It has 3D printers for prototyping and enclosure. It has workstations for doing testing and programming. And so you can make an entire, like, 1 to 5 or 10 pieces of something to make sure that it works. And then later on in the next room, we'll see what happens when you put the solder stencil into the machines and start doing everything automated. But this is kind of like ground zero of where you actually start figuring out how to make your design in volume.
Because this room is kind of challenging. Because
see, she's going to put it by hand.
By doing this for once, you absorb most of the mistakes and errors happening in your design stage. And instead of back and forth paperwork of DFM, our technicians here, they will do by their hand. And they have experiments on both ends. They understand about the mass production. They understand about engineering. So they will be, after they do it by themselves, they will come up with a report for modifications or improvements.
Yeah, when you know how to do something by hand, it really makes you appreciate how that you can do it with a machine. And also helps you to understand how to make sure to know if the machine's working correctly or not.
Yep. But this is difficult. You look at how the small components, they have to hand pick and put them onto that.
Every time I come to Shenzhen, I always go to the tool markets where these people buy their tools, because you can't get those tools in the US. But like the tools that are supplied to the people who actually do all this handwork are definitely the best ones. And there's nothing, you just have to know where to go. But you get those tools and you can go real hard in your home lab.
So once in a while, we call it a Shenzhen culture, right?
Shenzhen culture, yeah.
So, but I'm seeing it in a very positive way, because they're small teams. They can really form up to build an economy and really to resolve some problems.
It's very punk rock in some ways. It's very like, everyone's working together and maybe sometimes not respecting the corporate structures, which can be good or bad, but it forms
Are we going to talk about the corporate
it forms a whole community and people sharing skills and figuring out ways to get things done. Because
so there's a Easter egg here is David and me both worked for Intel.
Yes.
We get bored of the big corporations too early, and we have to think, how can we do things more agilely, small, but really to answer to the right questions. So we use a lot of the mass production techniques, but now we look at these small agile manufacturing problems. So that's what's happening in Shenzhen. A lot of the manufacturing, they start from the huge manufacturing offshore, outsourced to Shenzhen, but we are renovating all the process with other people.
You could take the learnings from that and start up a smaller operation where you take the skills, but you're not so encumbered by the structure of a giant company with someone. You can define your own processes and be a lot more agile.
Yep.
We were talking about, can we talk about the tubes?
Oh, okay.
I just really like this. This is one of my favorite things about factories in Shenzhen is they have this, they call this the lean tube, and it's this steel pipe that has plastic around the outside and these fittings. And so it just comes as a long pipe, and you get a bucket full of these fittings, and you can just cut the pipe to length and build whatever kind of workstation or desk or storage shelf or anything that you need. I know I have some friends at a company called Wazer who make desktop water jet cutters, and when you get hired at their company, your first assignment is to build your own desk. They just say, we ordered 2 kilometers of tube, and there's the bucket of fittings. Go over there, and like before you get to start working, you have to build your own desk.
Yep.
And so you see, depending on what's being made or what kind of factory it is, people just make build out the furniture as it's needed.
And we use a lot of the stencils.
This is like a speed rack from a kitchen. Like
because for each of manufacturing, we have some stencils. They use either for carrying things around or after it's being used, they becoming some like a shelf space for variety of things.
Yeah, that's true. So these are made with a laser cutter, right?
Yep, with laser cutter, and they're becoming so cheap, like about $10.
$10.
But it's a good material for making a furniture
too. Is this the solder paste fridge?
Yeah, this is a refrigerator to make sure that your solder paste is having the right temperatures.
Yeah. Ah, yes.
Yeah, they have data codes. Like how many?
2024, an excellent year. It's a wine joke.
Okay.
That's nice.
Okay.
All right, this is
Cool.
where.
Like we are recycling everything.
Yeah.
Because we have our maker spirit, people feel free to hack everything with whatever they have in the floor. Okay.
All right,
So this is going from 1 piece, 10 pieces,
10
all the way
pieces,
to several
all the way
thousand.
to several thousand pieces through this door.
Yeah. So this is a very straightforward single line, but we do most of the agile manufacturing small quantity here. And there are so many mistakes. We have a Buddha here.
Right. bless the manufacturing line.
Yeah.
I mean, one thing that really shocked me when I first started coming to Shenzhen and learning about manufacturing is I kind of always thought that once you hand the design off to the machine somewhere in China, like it's fine. But it turns out that there's actually a whole lot of work that it takes to actually make the machines know how to do all your stuff just right.
Yeah.
And so that's what happens in this room is figuring out how to get everything tuned in just properly so that it can be done thousands of times in a row.
I think in huge factories, the engineers will dominate everything, and the workers will just follow in the orders.
Yeah.
But here is people understand the context, and people know how to do things. People innovate.
Check out this machine.
Frank, 近一点.
So that solder stencil that we saw in the other room actually gets loaded into this machine. I don't think it's running right now, but it's the stencil goes in here and it actually plops the solder paste on and does it automatically. And there's a little conveyor belt that brings the boards through and puts the solder paste on. And then after that happens, should we look at that thing? That's a different thing. And then.
And this is new. This is a solder paste inspection machine. So it will, after the applying solder paste, the evenness.
It's happening.
It's working.
So it's inspecting. That red light means it's inspecting. Now it's brushing the solder paste across. Go up a little bit so you can see there. All that reflection. Yeah, so the squeegee is taking the solder paste across. And then it'll drop the board down, and then the board goes into the next machine. What's going on? Yeah. So then, so the next thing, so we go here. Let's go over here. Just gonna pull it back a little bit. Okay, yeah. See, it comes out.
Before that, we have a new machine here.
Oh, okay.
This is to inspect the thickness of the solder paste.
The thickness of the solder paste.
So to make sure like every part of the solder, after it's being applied, they have the right thickness and there's no like nothing missing. This is something wrong? 这是有问题是吧? Like extra solder?
That says extra solder?
Yeah, this is somehow like a y-axis offsets.
I see.
It will confirm if it's okay, and then move on. Before we have someone to look at that by eyes, or they just do it, but it will cause extra failures afterwards.
Right. So then it'll go through the inspection, and then it continues through on this little conveyor situation here, and then it'll go into the next machine, which is running. Look over here. So you remember these spools that we saw downstairs in the warehouse? Look at these spools where my hand is here. So these spools are full of all the components, and then this machine actually takes inside. This machine actually, this is called a pick and place machine, and it picks up the components out of the spools, and you'll see it. It's grabbing out of both sides here, and it actually picks them up and puts them onto the circuit board. So you can see the circuit board. You can see the circuit board in there. And so now it's plopping those components down onto the solder paste that was just put on the board.
And we have a special gear here. Let's go to the back of the machine.
Okay.
Let's go to the back of the machine. Because we need to change so many like chipsets onto the machine, that there is always not enough space. We have this guy.
What is this?
So I call it a chip robot. So you can put 150 different 15 different type of chipsets into this container, and it will be according to the demands to fit the
cool.
right tray onto the pick and place machine.
Oh, I see. If you have a tray, so sometimes the components come in a tray instead of on a reel. You can see it nicely from here. I love watching this machine.
You can see from here, it's not fully loaded yet, but you can have each of the tray have different types of chips.
Yeah.
So you can share this container and the pick and place machine for longer bill of materials.
I see.
And it's also part of our like open parts library. It's a robotized version.
Yeah. It's a robot that feeds the robot.
Yeah. Yeah, it's the robots feeds the robots.
We should get a shot of the inspection. Oh, well, this, yeah. So many things to look at.
Yeah, so after, for a whole lot, like no matter it's 100 or 1,000 pieces, whenever they install every of the pools, every of the components, do the first assembling, they need to make sure that everything is aligned. So they will, before it was done by eyes and assemblings, but before they get a solder, can just take it here, and we now have a machine that you can measure the key components and to see if it's matching.
Yeah, see, if you look here, this is actually, it's got the probe and is actually checking the values of the components and making sure that they're all soldered properly and that everything is connected well. What is it? Are these shows?
Yeah, they are the shell. Which one?
Which one is it?
It's a C6.
The 66?
ESP32 C6.
ESP3266, yeah. This is a very popular board everybody uses. They're fresh out of the oven.
Yeah, this is actually before the oven.
Yeah, I guess.
Literally before the oven.
Oh, I see.
So you see, that's where we need this kind of machine. You can just very quickly verify it.
Making sure that's right before it all gets soldered down.
Because all the quality control is we want to make sure all the things are right before the future stages.
Right.
The earlier we catch the error, the less fraction or loss we have.
Fix problems before they become problems.
Right?
Fix problems before they become problems.
Yes, exactly.
Can we see so this is fun on the pin place machine.
Yeah.
It has this camera that actually checks.
Yeah. This is a.
You can see it. These are little pictures of the placement of the actual component. So it knows, it checks to make sure that they're plopped down properly. The angle. You see, it's always different, just a little bit each time, because no machine is perfect. So this is always verifying to make sure that it goes down in the right way. Oh, cool.
Yep. And this is our guy from Samsung. So we have a 2 pick and place machine in serial, and we have a 2 person in the middle to do the inspections and to the needed processes.
Yeah. See, look, you can see it. These are this looks like what? This is like a USB jack.
Yeah, it's a Type-C connector.
And you can see each one is rotated a little bit differently, but it's checking to make sure that it's within tolerance.
Yep. This is still old school computer vision, but it works a lot.
Yeah. And then we have the oldest and most reliable school of vision, which is a person looking at it.
Yeah.
And so then once we know that all the solder paste is on correctly and then all the components are on correctly, then we put it through the pizza oven to make sure that to make it actually get soldered down.
Yep.
So the conveyor continues, and with solder, it's actually best to solder things in they call it a temperature profile. So you don't just hit it with heat and melt it and cool it down. You actually want to, depending on the formulation of the solder, you actually want to bring it up to temperature to make it more liquid, and then make the temperature go really high to fully melt it, and then bring it back down to make sure that it anneals properly. So this is a really long oven with many different heating zones at different temperatures. So as the board passes through, it gets exposed to the different temperatures to control very precisely how the solder gets melted and soldered on and then cooled down. Otherwise, you get weird cracks and other bad things happen, and it doesn't work.
You want to make some pizza out of it?
Yeah, we can make some pizza.
Yeah. You can make the most precise pizza
I bet you can
according
make
to
a really
tests.
precise pizza. You could probably do something where it melts the cheese and then toasts the pepperoni at the end or something.
Okay.
We should do that. That'd be funny. Get sponsorship.
Please.
Oh yeah, what?
So there's a typhoon outside with wind.
Yeah.
And it's so nice and cool in here. Does the wind ever knock the electricity out and you have to worry about it not being cool in here?
I think we never experienced that.
But also humidity control is probably important.
Of course,
right?
we have air conditions, and the
Yeah.
electricity is quite stable because we have so many factories here. All the electricity system they have buffers for that. But maybe because we haven't encountered a more like a stronger hazard. So far, it's most dangerous thing is typhoon.
Yeah.
Like we are facing a typhoon right now. It's supposed to be very heavy rain, but it was okay.
Yeah. Well, also
we
you
can,
know these sensors, these environmental sensors that you've been putting everywhere.
Yeah,
it's really
yeah.
good because a lot of like LEDs are really sensitive to humidity.
I
And-
think the thing is because we have a factory, everything is isolated.
Yeah.
But if we are manufacturing something different, like if we are manufacturing corn,
Yeah.
agriculture is a process of manufacturing as well. You need to be more adaptive to the environment. That's where you
Right.
need sensors.
Yeah.
And you need to adapt it to the products.
Right.
Because for agriculture products or cattle, it's totally different on each of them. We
Yeah.
cannot use AI like that one because everyone is different.
Yeah.
You need to understand more like tolerances to have the precision.
Yeah.
Okay, so
You
after
were
the
telling me about this. This is
exactly
cool.
that's what I'm talking about.
Yeah, yeah.
This is old school, boring, automatic optical inspection. It's just to compare between the two products to see if there's a difference or errors. If there is like this one, very slightly difference, the inspectors will be verifying if it's okay.
Yeah.
So if it's more like a enhanced AI, it should be able to tell.
right.
For now, it's just very straightforward pixel to pixel comparisons.
It'll tell you if something's different between the two, and so you
Yeah,
know
yeah.
where to look.
This spent us a few years to really decide to buy it.
Yeah.
Because I always think we can just build one for ourselves, but we never had the time to do that.
Yeah. And sometimes it's better just to buy something that someone else has figured out, even if you know how to build it, then you can do something else with your time.
Yeah. So this is after the oven, after inspection.
What is this? What are we making?
This is a little robot we make it for Tencent.
Oh,
That-
can I pick one up? Or
I
no?
think it's okay.
Okay.
Yeah.
So I bet this is like some kind of distribution. So I bet these are like, oh, these are for Grove. These are Grove
Yeah.
connectors.
So this is actually the core board for our car.
And I see an ESP chip on here as well.
Yeah. So it's based on the shell, and we modified it to have a different setup for Tencent. They are doing the educations.
Yeah. Cool. I like this solder mask. It's kind of matte black.
There are a lot more fancier way of doing that,
Yeah.
but this is still the easiest and the good yield. But after the SMT surface mount, this is our magic. We like this machine so much because it's a select.
in that old factory video we were watching, they just had a big pot of melted solder that they would dip the board
Yep.
in. But this one actually has a
Really like an oven now.
yeah. Can we open this door?
No,
No.
but you can see from here.
Yeah, maybe you can see it from there. But you can see that there's actually a bead of like, it's a very little tiny tip of melted solder that when the board comes through, it'll stick it up and drag it along the board. Maybe, okay, I think one's coming in right now.
Yeah, it's coming.
Yeah, so you'll see this melted solder right here will just go up and bloop onto the, is that a technical term, bloop? But it'll go onto the, exactly where you want the melted solder on the board.
So it's like a very precise
Look
fountain.
at that. Yeah, a fountain.
A fountain of solders goes into the right place.
Yeah.
Most of the manufacturers don't have this because whenever you want to manufacture in large quantities, you just make a mask
Yeah.
to make sure you solder on the specific points. But we have so many different products manufactured here, and it's better to have digitalized, customized for each of them
Yeah.
instead of making 100 types of mask every month.
Yeah.
Okay.
And then it'll come out here, and so I guess he's taking the, so see, they just put some tape on the parts they wanted to shield from the heat.
Because some of the components they are very volatile to high temperatures, you need to shield them a little bit.
Yeah. So how many different colors of PCB can you make?
Colors,
Yeah.
endless.
A lot, right?
Endless. Now we have fancy ways of to have silk screen,
Silk screen.
like a full color silk screen on top of that.
Yeah, because you can put multiple colors of solder mask and silk
Yeah,
screen
yeah.
and do multicolor printing.
But it's fighting with 3D printers. Whenever you
fighting
have a
with 3D
different
printers.
color,
Yeah.
you can choose all kinds of 3D printing materials and finishes.
Right.
So the silk screen or color of the PCB is not that important now.
Right.
Okay.
Yeah. All right. So now that the board has got all the components put onto it.
Yeah. So this is after that they have extra parts. What's that? What's this one? Oh, this is gas sensor for groove.
This is a gas sensor for growth.
Yeah.
So if there's anything that can't be done with machine, that's then when it comes to the hand stations. And so
Yeah.
for each product, each of these workstations is set up according to the requirements
Yeah.
of each individual product.
Because you see the gas sensor is too big. And also it's volatile to the high temperatures.
Yeah.
So we have to hand solder it afterwards.
Right.
And this quantity is very small. I think we are manufacturing 250.
Right. Yeah, and that'll take somebody like an
Yeah.
hour or two.
If
to
we
make.
ship this to another factory, bigger ones, it will take a lot of time to set it up,
Yeah.
to do all the preparations. But here, we just like
Just
very
have somebody
efficiently
do
go
it.
ahead with
Yeah.
other orders. Okay.
And so each product has its own final assembly steps and then testing routine.
Yep.
So they make these test jigs. You'll see these all over the place in Shenzhen, these black boxes. And so depending on the product, they will customize it. So if you need some specific tests, you put your own, these are other shells inside of here that you program with Arduino or something to like run through the different tests that you want.
Okay.
So
So what's happening here is we are using two shell to test another shell.
yeah, exactly.
So it's a fun for our
And then
test
this is-
engineers.
Yeah, then this is a machine piece, and then the board will fit onto this. And you
Yeah.
can see down here, there's some like pogo pins. These are like, so these will touch on test points on the circuit board, and then when you press this button, it'll do whatever thing that you want to test.
Yeah, and we have on/off switch.
And so whenever you want to make a board, these are like not that expensive to make. These are like a couple $100 to make
Yeah.
because this is a generalized frame, and then you just put whatever you want to into
But
it.
what's really expensive is inside. Like how
Yeah.
do you do the programming? How do you do all the test items?
Yeah.
So we are trying to make it open source. We are trying to use more like advanced assistant to do that.
Right.
Because programming a microcontroller to test a microcontroller is
Yeah.
still some engineer work.
Right.
But now we are trying to switch to Raspberry Pi.
Yes.
To use Raspberry Pi and Node-RED to do all the testing.
Raspberry Pi and what?
And Node-RED. Node-RED.
Node-RED.
It's on like a low-code
Node-RED,
system.
Yeah.
Okay,
And so
you-
you see how these guys are.
Yeah, you see that it's the same test stencil. We are doing the testing on the shell.
Yeah.
You
So
come
we'll
and
bring-
see it.
These are unprogrammed ones here on the right, and then put one into the test jig,
Yep.
and then the little pogo pins make contact.
And each of the product has a SOP according to the test plans.
Standard operating procedure.
You know that.
Yeah.
So they will be following that.
And so if you look at the screen there, you can see at the
screen.
computer screen, you see the factory operator has a document which shows what the customer wants them to be looking for, what the actual procedure is for testing to determine if it's good or not.
Yeah. And we also have our MES system to like apply all the procedures onto the manufacturing floor with the pad. But now we are trying to link everything from the tester jigs to the pads, SOPs, so we can have a fully connected digital manufacturing means.
Right.
For now, I think it's still, we don't have enough attention on our own manufacturing. Now we are trying to change this. I will show you more things we are working on. And if you see this kind of test stencil, which means it's in early stage, we tested one shell at a time.
Yeah.
Whenever it goes into much larger scale, we simplify the testing material to make it more efficient. We test like tons of them or dozens of them at a time.
Right. What's this thing?
Yeah, and also what you see is about the microcontrollers. We also have a single board computer like for this is Jason. This has It's just O-ring, and we are programming it. We are trying to.
You're loading the code onto the. This is the SSD that goes in the Jetson.
This is a customization. Like people not only buying the full hardware, they want to have their own firmware. They want to have their own systems.
Right.
They want to have their own configurations, like a different size of SSD storage. So we also help people to do that through our Fusion service.
Right. Oh, source and target. So see, this is just the source one, and then when they want to put copy whatever's on here onto that.
Yeah.
So you can do a lot of them really fast.
I think sometimes we should like sort how many types of test jigs and procedures we have. It's endless.
Yeah.
Because we answer to so many bizarre demands, including ourselves.
Yeah, one thing that was a big learning for me when I first started working on having things made in factories is not only do I have to design the product, but I also have to design a testing program for it.
Exactly.
So like writing the code that goes inside the test jig, because you have to be able to explain to the factory operator what they should be looking for to make sure that your design works. So it's kind of actually two design processes. Like you not designing the product for yourself is not enough. You also have to design the procedure that you can give to someone else to make sure that they made it right.
And most of the time, like testing, the cost for manufacturing is on the testing.
Yeah.
Because it requires a lot of hours. Machines are quite standard. Whenever you see from the first part, it's very fast and easy. So SMT, automated, AI, but after that, it's all the quality controls, all the yield, all the durabilities. They are done during the test process and the verifications, calibrations.
Right.
And it's a very different per product.
Yeah, it's very different per product.
And you can see from here, we are testing the first watcher. We are shipping the first batch of them very soon, and it's going to be on Kickstarter, I think next week. We just finished the video. I think whenever you go back to the office in the afternoon, you can check out the video.
Yeah.
It's quite fun.
So see, they're making them right there.
Yep. We can go check it in the details.
So this is a integrated box with a camera that does different kinds of detections, human detections, animal detections.
Yep. This is one of the early samples. Like we try to integrate the AI into it, because we think people should have a device to link between large language model and the real world, and you need to have something to talk to it.
Yeah.
And by the first step is
it's detecting us as people there.
Yeah. First, it needs to understand there's people in front of it. So we don't do it in the cloud. It's totally happening inside the little device. Because with the latest NPU, you can have several frame per second good ratings of person detection. But you can also apply to other models. Then after this model, after it has been telling what's happening, they will send the data to the cloud, to like ChatGPT or other large language model to have deeper understandings or interactions.
Right.
So this is basic. This is for developers only. But in the next future, I think if you go to like a kiosk, you go to a retail store, you go to a hotel, you talk to this guy.
Right.
It should recognize you, help you to check in, to help you to do all the services. It's like in the car I'm driving here, like you just talk to the Neo, and it will be answering to all the questions, like controlling the environment for you.
But it's important to like encapsulate all of that inside of a single physical object that just gives you an output of like.
So this is more like a reference design. So we give people, okay, we now can integrate everything together, and it's open source, and you feel free to use any of the components inside this design. Like we were talking about OpenPath library, this is also a cluster of OpenPath library.
Right.
You can choose to remove something, like you don't like the screen, remove it, so it can become smaller and cheaper. And if you want to add some groove sensors, we have it already.
Yeah.
We have
you can plug Grove in right here.
Yeah.
Yeah, it's got the Grove. It's got the Grove header.
So it's not.
I love this wheel too. This wheel is very fun.
Yeah, because whenever people wear some gloves,
yeah,
it's hard to touch. So the wheel.
I don't like capacitive touchscreens on things. Capacitive touchscreens I think are hard to use. I think it's nice to have buttons and wheels and things you can do with your fingers.
So we have a belief that in the near future you can just talk to things instead of programming it.
Yeah.
The best way to program it is to train it. Tell this guy, the little robot, what do you want to do. Yeah. This could be the head for the machines or for the rooms. And we're getting there by testing them.
Look at this test jig. This is a complicated test jig.
Does she test every one?
Yeah, we have to test everything.
Everyone, no sampling.
No sampling. This is fully test.
So
And you see, we are using a Raspberry Pi HMI. It's called Reterminal. It's our own product. We use this to test the other products.
So you designed that?
Yeah, we designed this, and they are assembled right in this factory as well.
Wow. This is great.
Because there's so many functions inside. It has speakers, camera, it has displays. It's a small device, but it's very similar to a mobile phone. We need to verify so many details of that, and it happens in this machine, but it's not enough. Like that previous shell is easy, but we need to use a Linux system to test that.
See what happens. You're gonna push the button, plug it up. So, also when you're making like a whole lot of something, you actually want to think about how long each testing cycle takes.
Yep,
Because if you're making thousands of something, saving a couple seconds actually will save you a lot of money.
exactly.
So you actually want to like optimize your.
This actually is the ultimate battle happening in the manufacturing floor. It's between the cost efficiency and the quality.
Yeah.
You want to use the least efforts to
See, I don't know if
guarantee the
people can read
maximum
it, but
quality.
it says speaker test, everything test, open codec test, seed command test over.
这个声音是什么意思
That was testing the audio. That beep was testing the
Okay.
audio, hearing.
So the noise is from the device. It's testing the speakers.
Yeah. This is testing the LEDs. If the LEDs are blinking, it's testing the LEDs to make sure they work. Watchdog timer test. Yeah, it's going through like every single function.
Maybe in the future, the watchers can.
Oh no. Oops. Come back.
It's okay.
And we're back. Maybe there's some interference or something.
It feels like so. Stay away from that.
Yeah.
There's some magic happening. So maybe in the future, the watcher can test the watchers. So we get two watchers talking
Battery
to each other.
power test, upload test, pass, done.
Yep.
And now they unplug it and put a new one. And that's one whole test. Cool. And then it goes onto the stack of finished components. And then now they put another one in and rinse and repeat. Yeah, cool. All right, let's move. Great. And then you end up with this.
So maybe in the future they can test each other.
So where do you think the next steps of like automation are in the factory? Like what's the future of automation?
You mean the future or the future and the future?
Any future that you choose.
In the future you choose, I think ultimately it's fabrication from atoms.
Mm-hmm.
Like
From
you,
atoms?
yeah, you just like fabrication everything like a replicator.
Right.
But I think for the next stage, at least for our factory, is how can we make everything more connected? All the testing data, all just treating. Each factory is different. A lot of factories, they are caring about the safety first.
Right.
Then it's about the yield, the quality. Then it's about the yield. But for our factory, and of course, safety is still the first thing. But on our yield is how can we manufacture as many different types of products as possible every day. So we have to optimize on that part. And the overhead is usually on the process. How can we set up the manufacturing for different manufacturings?
Right.
So for other factories, it might take a few days to really set up for a whole line for manufacture for several tens of thousands of them. But for us, you see most of the workers, they are like solo. They are one man's or one lady's station to handle one complete product. So it's a different training, it's different automations.
Right.
And actually, I'm very, unsatisfied for what current machines are.
Right.
Every machine we can buy is outdated. We want to use open source hardware to renovate what's happening in the manufacturing floor, especially starting from the test machines.
Right.
The testers should be a lot more automated. And it should be like Linux based. So you can feel easy to change them, even there's no engineers around.
Right.
And with AI, you can test them much faster.
Right.
And also there's another methodology called DFMA, where is from the statistic results of the manufacturing floor, you can predict what kind of failures in the future.
Right.
So this, for now, it's a statistic, But with GPT, with more like methodologies, I think we can renovate that.
Do better predictions.
Yeah, you should have like a AMC GPT, Agile Manufacturing Center GPT.
Agile Manufacturing Center GPT.
Yeah.
Yeah.
You see, I don't know how many test jigs or processes we have, but if there's an AMC GPT, I can consult that.
Right.
And also with all the wearables, with all the gears, you don't need machines or like computers. You can wear the equipment.
And see augmented reality.
Exactly.
On top of everything.
And you can move around instead of the units moving around.
Yeah.
So we'll keep doing, but the first big challenge I think is on the testing. And if any of you are interested, we will gradually open source our way of testing.
Yeah.
And for our customers, it's very important to understand how we tested that.
Mm-hmm. Yeah.
Okay, like this is for Jason. After you do that, it's we connect. This one is already connected to the mesh. Let me show you here. So this is Recomputer G1020, and this is the semi testing. These use multiple terms to. Oh, okay. They will read all the processes, and this is full number 200, and we have passed the 164, and this is the yield, and it's on counting. And we have SOP. Everything is connected, and it's linked to our ERP system. Okay. I think we can move on to the assembly part.
Assembly. So this is final assembly.
Yeah, this is the biggest gear we have is workstation.
Mm-hmm.
I think this one is not published yet.
Oh.
This is like a
special sneak preview.
Yep. This is a workstation of 10 elements. From the
workstation of 10 elements.
Yeah, this is for rainfall. This is for nightness. This is for wind direction and speed. And inside of these cabins, we have temperature, humidity, or variety of gases. Mm-hmm. But
what is this?
This is you see previously you tested the rainfall with a barrel.
Uh-huh. But it collects some rainwater.
Collects some rainwater. Will flip whenever it's reaching some measures. But it's very maintenance heavy. Mechanical, yeah. And if there's some leaves inside, if there's some bird feathers inside, it'll mess it up. It will mess it up. You have to clean it. If you install on the high roof on the chimney,
now you have to
difficult.
climb.
You have to climb it. So we are replacing it with the optical. So whenever there is a drop onto it, it will counts it. Mm-hmm. So this is a new version.
And can it tell the difference between rain and hail and snow?
No, this one does not.
Yeah.
But this one will.
This one will.
This is new. This is not published yet, and we are using now radar to tell of the rainfalls.
The type of precipitation.
Types of
precipitation.
Precipitation.
It's a good word.
From rain, from snow, from hail.
Uh-huh.
So we have insurance company wants to know who is destroying the crops. Mm-hmm. Now you can tell it's hail, or it's just some fake news.
And see, he's assembling the.
Yeah, he's assembling the unit. You can see what's inside. And maybe you can see we use epoxy on all the circuits. Mm-hmm. So this one has to stay in the wild for several years, in the worst scenario, because you put it onto the roof, or put it onto the window generators. Mm-hmm. It's huge wind, vibrations. It's a lot of sunlight. Yeah. And different temperatures. Sometimes it's minus 20. So you have to make sure these guys work for a few years.
Yeah. It's usually installed somewhere that's kind of hard to get to. So you have to design it so it can really stay there without needing servicing.
We actually spent a few years to really build this to last and precise and working. And
how did you decide what plastic to use?
Sorry?
How did you decide the plastic so it would be very
experiments.
Good for the
we test all kinds of equipment. Because if you want to just be waterproof or sunproof, it's easy. But how do you do that for an instrument? Because, for example, we have ultrasonic sensors, transponders. They will tell the wind speed, and they will be reflecting to the upper layer. The finish and material of the mechanical part will affect that too. Yeah. So it's a lot of physics inside of this machine. It's not just electronics. Mm-hmm. But we did this from like 5 years ago because we see so many makers want to make some very useful device for agriculture or for environment monitoring, but they cannot do that. It's too difficult to make it last. Okay, so why don't we just do it for the makers? So we did the housing, we did all the enclosures, all the LoRaWAN sensor for outdoors. And now we are applying more technology into that, like the radar. We are applying Meshtastic into this.
Meshtastic?
So,
yeah,
Meshtastic.
Yeah.
We did a few live streaming. Is whenever you in the wild, there's no infrastructure, no communications, you can relay the messages. We sold this a lot to the forests to prevent forest fire. So the inside of the forest, this can be communication relay station. You go out hiking or rescue or firefighting, you see the positions through these devices. We will have some explanations on that. And the wind direction and speed is very important. Whenever there's fire, you want to know where to put it out. Because you cannot just look at the satellites. In every valley, the wind direction is different. You need a lot of microclimate data. And especially farming. Whenever you want to grow something, for this a little region, it's different from other regions, even they are in the same city or same county. So this goes on. And one important thing is about how do we measure the precision for the wind. And there's no place we can easily find some measurements, and we have built the wind tunnels.
Right.
Let's go downstairs with this guy.
Yeah. Let's take it.
Yeah, 我来吧，我来。
Ride the wind and waves.
这个。And you see, we are trying to set up a full digital solution for our factory. We are trying to connect more like test machines and also safety means, environment, sensor data into that. And this is some of the applications we have done, like you see there for farms in Malaysia.
Durian sensor?
Durian farmers, because it's expensive fruits, you want to make sure they are in good condition. You need to cater to them. And because of climate change, you cannot do it by experience. You have to have data.
Yeah.
And we do it for pig farms. Like you cannot use AOI to check the pig farms. You need a more deeper AI to do that.
Yeah.
And this guy goes to there as well for the wind generators.
Yeah.
Because there are so many wind farms. Yeah, it's the same device has been standing there for 2 to 3 years. Now we are deploying them in a larger scale. Like this is in Italy. They want to know the heat map of this city. So they want to have mitigations, or after the mitigation, like forest restrictions, they want to know how it's improving. So they need more microclimates. Like warehouses, we have this in our warehouse too, manufacturing floor. What's happening inside with all the person detection and post detections. This is just a start. We are trying to educate or train our persons inside the factory so they can ask for what they want and they can try to build the system by themselves. I think one major task for us is to make them simpler so more people can do it. And here are some of the visits. And here is a very interesting one.
Yes.
You know, have you met BK?
I did not. I think I was at Intel before BK was there, but.
Yeah, but BK was, when I was in Intel, he was the boss.
He was the boss's boss's boss.
And during the maker movement, he came to our factory, to the Agile Manufacturing Center to understand what's alternatives to mass productions. How can we answer to more diverse demands of the maker scene?
Yeah.
So it's quite a proud and
seems like they're excited about it.
eventful. Yeah. Because this is something really different.
Yeah.
Okay, let's go down to our wind tunnels.
Go to the wind tunnel. We left our. Should we get our clothes back?
Oh,
We'll
let's
get
do
our
it
clothes later.
downstairs.
Yeah.
And we ask our wind tunnel to stop, to pause for a while.
Yeah.
So we can get this one into testing.
Yeah.
Because each of the weather sensor needs like 40 minutes to test, to calibrate.
Right.
Wow.
With different speed, different readings, and it's science equipment. These are not the most precise one, because that's going to cost like a million RMB, like hundreds of thousands of dollars. But this one is industrial. It's between your family weather station and the precise ones.
Right.
This is good for industrial use, like for the wind generators, each of them has one of this device.
Right.
So we are more than just making electronics. We are making more equipments.
Yeah.
It's
raining outside. Here we are.
Where is Frank? Welcome to our wind tunnels. So you'll see more babies here under testing. And
look at this thing.
Oh, he has one already, so I will just put it on here to wait in the queue.
And here's one we made earlier.
So it's a machine that, how many meters was that? About 20 meters?
20 meters.
So this room is about 200 square meters, and it's.
So you guys designed and built this thing?
No, the wind tunnel is quite like a presets.
Hmm.
It's a very professional machines. Just we cannot find that in Shenzhen, and we have to build one.
Does it show?
So we put each of those devices inside, fix them firmly, because we are going to have 8 meters per second wind blowing them.
8 meters per second wind blowing.
You will see they will start the testing. The noise it will be quite noisy. And what you see in front is actually a huge loop.
Mm-hmm.
The fan, a huge fan, will blowing everything circularly.
It's all over serial port.
Yep.
Make sure that USB connector is connected.
Do you turn the device to make sure the directional sensors work?
It's probably the fitting.
There's a fixture
The
underneath.
fixture makes sure that it is.
You see?
Okay.
It's already turning.
Okay, yeah.
Look.
So it's rotating to test a different angle.
Right.
Because it's not wind speed only. You need to test the different directions that the readings are precise and calibrated in different levels.
Mm-hmm.
So that's why it takes 40 minutes.
Yeah. So is the wind running right now?
Let's see. I think it's just starting. Like it's 5 meters per second. You know, I don't like these machines because they are running Windows.
Yeah.
They are so outdated.
Yeah.
They are not automatic. So one machine at a time, we are going to revolutionize them. We are going to upgrade them with single board computers. So now it's about 9 meters per second.
I can hear it. Yeah, it's going.
And you can see we have very, very heavy structure here. It's like tank. Because the wind here will be speeding up. Mm-hmm. The wind will be like pushed to this space. So it has a faster wind speed. So you see, it's still a lot of manual work to switch back and forth.
You can see on the wall over there, there's a diagram of the whole wind tunnel. I see, so they're ramping it up and testing it different ways.
Yeah.
Who makes the casings? Who makes the enclosures?
We make it.
Do you?
Yeah. We have to do a lot of experiments, calibrations, like also we use AI to do this, to do the design. Whenever you want to understand the materials, because there's several
material properties.
Yeah, properties.
Where do you make the enclosures?
Show us the.
We also set to the
there's like
mold
a diagram of the layout,
and
we can walk over there
the
and see it.
manufacturer, we come back, we
It's hard to
inspect
see
all
the
the
whole
details.
So that's what the whole thing looks
Yeah,
like.
like the arrows, precisions. Yeah. So that's a cylinder. It's a how say the raised lane for the wind, for the airs. And the maximum is like 80 meters per second. It takes 5% to ramp up to 50 hertz. Mm-hmm. And this is the angle for the air deflections.
Yeah.
And also it has the stability to maintain minus 0.5%, velocities, turbulences. I can't just read them. I'm not sure what they say, but our engineers has all kinds of details covered. Yeah.
Right.
So it's only 0.6 meter by
That's
0.6.
just the test chamber itself.
Yeah,
the rest
yeah,
of
yeah.
this is dedicated to making
You cannot
the wind
bike
flow.
inside.
Yeah, you cannot bike inside. Test your biking performance.
Okay, so that's our wind tunnel. And this wind tunnel now is running like 24 hours because we have so many wind sensor needs.
To be
And
tested.
we have to test them. Yep.
Yeah. Cool. So now we go in here. This is the loading dock. Shipping out, right?
Yep. This is like a final stage. After we manufacture everything, test everything, and
Smells like cardboard.
calibrate everything.
I like the way that
You
packed
smell
up
it.
devices smell.
The
Cardboard
smell
and
for the
packing
carbon
tape,
is so good.
Uh-huh. Finished. Nice
Yep.
and done, yeah.
There's two smells I like most. One is fireworks.
Fireworks.
The second is the
Is
carbon,
cardboard,
carbon
yeah.
boxes.
Exactly.
Because whenever you smell this, you feel like it's about to be shipping.
Yeah, exactly. It's just all in here.
Yep. And here we package everything. But this is just one of our warehouses. This is the main like distribution center. Then we send the goods out to United States, to Europe, to other spaces. And now we have 3-4 warehouses all over the world.
Mm-hmm.
And here we inbounding things coming. I think you are familiar with the warehouse too. They are just coming to vertical, but we try to make this more vertical.
Mm-hmm.
So for them, it's much easier to process orders every day. And we have hundreds of orders. It's in the morning, in the afternoon, it will be filled up. And we will have a lot of distributors, so we ship in big containers. And we have all kinds of heavy lifting machines to do that. And because it's a warehouse and it's environmental sensing, and we're trying to put our LoRaWAN sensors into this to monitor them. And
Right.
for dangerous hazard like batteries, we have a special storage room, and we link everything to this stage. And in the near future, we can apply more AI. And one mission for us, I think we are going to show you in the near future for the live streaming or for video is how can we use more digital means for our own operation.
Right.
Okay?
How long do the batteries,
Wait.
how long do the batteries last in the weather stations?
The weather station itself has no battery. It's connected to external like solar panels or power feeds. But for these little sensors on the wall, these little gray ones, because you might want to deploy it everywhere where there's no sunlight.
This is a camera, right?
No,
gray
that's
thing?
a temperature sensor.
Oh,
but we have a camera
okay,
version
yeah.
for that. That guy is, the battery life is 10 years.
Wow.
Yeah.
10 years, 10 kilometers transmission.
Wow.
So it's very disposable, and you can put it somewhere and forget about that.
I remember over at the office, I saw that they had something that looked like that, but it had a camera in it, and they had it pointed at a plant.
Yep.
And it was programmed to say if the soil was too dry,
Yep.
just by looking
It's
at
a, it's the same system.
it. Yeah.
But for us, the sensor head can be diversified.
Mhm.
You can connect to all kinds of gears.
Yeah, modular.
Yeah.
Modular design.
It's a data logger. Okay, I think we can go on to have a seat.
Yeah, let's go up to the sit down.
Frank, take care of the steps.
Yeah. Shaoxing. Have this little
Well,
desk set up.
so we try, every new year we try to collect some some tools from everyone to take a group picture. So this is the gears and tools we have for the from our AMC. Okay, I think first we.
Yeah, we're gonna take some questions from the chat.
Yeah. 怎么往上翻？哦 Okay, let's-
Is my audio level still okay with it right here?
I think so.
Okay.
You can write by yourself.
Yeah.
Okay, let's see what I can. Question have. Automatic is not always a good choice. Sure. Media is not about personal, but it's
That's my brother.
Oh, you have a brother here.
Yeah.
Citric.
machine.
Uh-huh.
They have a banding machine, a machine that puts the straps around it.
Yeah, sure. But somewhere. You see
It's
we're
in there
bending
somewhere.
that?
Yeah.
We don't in Magic, we have some machines for that. Shark face?
I'm in the McDonald's kitchen.
We have too many series. Okay, I think there's no specific question
There's
for
no
now.
specific questions.
But please keep it going if you have any questions about what we showed you today. And I'm happy to answer like during this live streaming or afterwards. You can do that in the chat.
So I guess we were talking about like the future of upgrading things. You think it's mostly as part of the. You think the next big area to be improved is in the testing and programming and QC sections.
Yep.
Maybe applying like larger scale AI tools to predicting where the problems are going to be and optimizing that part.
I think for different factories, it has different purpose. So the upgradation is like needing towards different ones.
Right.
Like for us, I think the biggest obstacle is how can we enable more new ideas be scaled. And manufacturing is a bottleneck for now, because a lot of people don't know how to verify their units. They
Right.
verify by hand or by their professional tools, and they come to us want to manufacture for 1,000 pieces. It's becoming a bit difficult.
Yeah.
And if we can share like more open source our test jigs to the people, to the designers, they understand, okay, this is made of, assembly is okay, but after that, the testing is done by this way in larger scale.
Yeah, the
If they
design
have-
process has to extend all the way through until
Exactly.
it leaves the warehouse.
And I think by doing that, people can get their things made much smoother and easier. And that's usually, how to say, slowing down the manufacturing process because of that. And previously it was injection molding. It would take a few months and takes a lot of back and forth conversations to make sure it's really working. And so test jigs, I think, is most
How do you
important thing.
find working with? Do you feel that 3D printing is starting to replace injection molding at lower quantities? Like, do you think that 3D printing is, if you want to make 100 or 1,000 of something, do you feel like 3D printing, you can start using a 3D printing process instead of having to make a mold for those?
Of course, we see that happening more and more. And there is a project there's project we have done for several thousand pieces by 3D printing. And this will be in our next live streaming next week.
Oh.
So we are having more and more small to large scale manufacturing because the quality is quite okay.
Yeah.
And people, if the customers has understanding, okay, this is 3D printing is durable, it's solid, they will accept it. We're encouraging more enclosures made by that.
Right.
And you see the new camera we are making. There's a new AI camera we are making. By default, we 3D print some of the mechanic parts.
Yes. What 3D printing processes do you guys use for these things?
Process?
Like, is it mostly FDM stuff, or
FDM.
It's mostly FDM?
Yeah, because it's FDM is good enough and cheap enough, and it's durable and it's versatile.
Yeah.
And there are so many services. We don't do it in house. There's so many services. Like 3D printer farms can do that very very nicely.
Right.
But it's the same. Even
Well, it's like it's nice that you can send this out. Like Neil Gershenfeld, who we know, the Fab Lab guy, always says it's cheaper to ship bits than to ship atoms.
Exactly.
So if you can make a design that goes to a digital manufacturing process, you can send it to different manufacturing centers, and then they can all make the same thing. And you're not having to like machine giant pieces of tool steel for your injection molds and send them around.
I think that the 3D printing maturity is a very important factor to that. Like we were sharing during the Fab 24 is maybe there is some step in between, like from fully centrally manufactured to distributed manufacturing from scratch. So we should be able to send to shipping the electronic parts or some core modules all over the world, but the mechanic parts, especially if you want to infuse it with existing machines, happens locally.
Right.
That can save a lot of energy. So it's another open parts library, or it's like an open device manufacturer to make a solution.
Yeah. I think standardization and modularity is an important thing.
Okay, we have some questions.
I have a question from the chat.
What's the question?
It's about the 3D testing, and then
Okay. So I think the question can 是哪个？
那个 Lily 发了个 great question，然后上面那个。
Rather than working to improve the cycle time for testing and verification, or the process is being investigated to make it so you can move to a sampling plan rather than 100% testing. So the question is, at what level do you start just doing samples of the whole batch rather than testing every single object?
I think for complex systems like a watcher or where you have devices, gadgets, we do 100% all the time.
Right.
But we might be reducing the test items.
As it becomes more mature, as you get more used to making the thing.
Exactly. That's where the statistic come in. We have more data during the testing. We know the failures. We know the failed items. We know the correlations between different factors. So we can choose to remove some of the testing items.
Right. It also probably depends on the project too, right? Like some things made out of really well-known processes can go sampled, and some things that are like brand new processes where everything's crazy at first to understand.
I think back to my job in Intel was to squeeze that.
Yes.
In the beginning, you test a chipset for like 1 hour, but gradually you reduce, and to improve that, to optimize that, you just use a few seconds.
Yeah, and you kind of start to get a feel for what goes wrong and like what to look out for.
It's not a feel, it's more like data.
Data, yeah.
Results and a very strict process. But I think we have to do it with designers a lot. It's not only by ourselves, but it's working with designers to improve that.
Right.
And I think through the open source community, we can do it better and easier. And I think there's another methodology we are changing is previously we want to give people all the ingredients so they can build something on top of that. But now we give people a finished product and open source that people can just trim it or to change it. That's much easier. Remix. And we encourage more derivatives. Yep. I think we can keep the questions for later. And tell me what you're feeling about Shenzhen now.
It's very different than it used to be. In some ways, it's like, I don't know. It feels like when I first. It's like when you see those videos of like a rocket engine starting up, where there's like a big explosion at first, and then the fire gets concentrated.
Yeah.
I feel like when I first started coming here, it was like the big explosion where everything was crazy. But now I feel like it's becoming a lot more focused. So in some ways, it's less crazy, but it's also like more intense.
Yeah, it feels like very much like ecosystem.
Yeah.
You have too many like blossoms, and everybody curious about what's happening in the economy. And after COVID, after so many things changed, whoever comes to Shenzhen are real serious.
Yeah.
And they are really efficient and resilient.
It's true. It's true. I mean, this place has changed a whole lot since we first did this tour 9 or 10 years ago. I mean, I guess it's a different building now, but it's the flow inside the building makes a lot more sense. You can tell there have been a lot more learnings that have been applied to the different parts. I mean, we talk about continuous improvement in manufacturing, and it seems like a lot more care has been taken. One thing that I really like about Shenzhen is that it's very like, let's build something. So sometimes you see things that are like, why did you make that? But you made it, so that's cool. And then you see things that like make a lot of sense. But now it seems like now that we're on the second and third version of all the factories and everything, it seems like all the learnings are being crystallized into a way that like really makes sense and takes all those factors into account. Like even just the way that the parts and materials flow through the building, and like where each of the different rooms are, and adding those machines, like even the machine you said you didn't think you wanted to buy, but now you bought it, is there. And it just seems like the flow is a lot more smooth. Yeah.
And I think the change is more like a cycle. Like each of the cycle takes about 10 years.
Yeah.
At 2008, we come to Shenzhen where we started the company, which was just in the middle of a disaster, economic recess.
Yeah.
But after many years now, we feel like we are in the recess, but we see a lot of new possibilities. We see a lot of new willingness to change or do things in a new, different way.
Right.
But I still miss the pop-up factory we did in SolidCon.
The pop-up factory. We should do more of those.
We should do
see
more
what
of
the
that.
next-
We
see
should
what the
bring
next
more.
pop-up factory is like.
Actually, I feel the Sales Zero has a lot of synergy between the Fab Labs. If we can make more Fab Labs or more makerspace be ready to deliver solutions, and I think we can have more hybrid, shared manufacturing process.
I think that there's a lot of institutional knowledge right now in kind of the maker movement and the Fab Lab movement where individual people have learned these like engineering skills to make one of something for themselves. But I think it would be really interesting to see how to apply that mindset to making hundreds or thousands of something. Like what does like a maker factory look like, or like a Fab Lab factory look like? And I think before there was a problem with people who without engineering training needing to learn how to do soldering and electronics design and use Eagle or KiCad or whatever. And I think now there's enough of a culture of maybe people who don't consider themselves to be engineers, but who have learned how to use the laser cutter and learned how to use the machines and have this knowledge that before was only limited to engineers. But now I think the next step is figuring out how to take that mindset and go to the next level of how do we take that culture and be able to make lots of things in a sharing and open source kind of way.
Yeah, I think so. That's why I think your visiting here is very critical. Like David has a very special background. Like, you were like electronic engineering at the start, but all the way into media, into all kinds of cross-culture understandings. Because I think whoever wants to explain about manufacturing are boring, like me. But you know how to express that in a very good way, and you can really understand who is interested in this and what's missing in their mindsets.
Yeah, well, I mean, that's why we need more people. We need more people from different cultures and different genders and different backgrounds. Because I think it's really, one thing I've learned in my life is it's really powerful when you kind of cross-pollinate the different backgrounds and mindsets. Like I was telling you when we were working on the Alike band with Marcelo in San Francisco, we needed some people to help us assemble. And you know, you can't find engineers off the street who want to assemble circuit boards, but we just said, hey, if you have experience designing jewelry or like, you know, doing art or painting or something like that, it's the same.
For industrial usage. You can see in our manufacturing floor, we do it for HMI, for
I always wonder when people say Raspberry Pi, do they mean the actual like Raspberry Pi, the computer with the Broadcom chip, or the Raspberry Pi with their custom silicon, the RP20, what are they, 2050s
I think the majority
now?
of people still say it's for a single board computer.
I'm very excited about their microcontroller. Their microcontrollers are really exciting, especially with those PIO modules that you can reprogram. It's very powerful.
Yeah.
And you can plop those down onto any circuit board that you're making. It's so cool that you can buy the Raspberry Pi. What is it? It's the Zero, right? The Zero has the RP 2040s or 2050s on it. I should know this, but I just bought the Shao anyway. I just have the RP 2040 Shao. Yeah, but I mean those are great because you can get the development board and then you can actually buy the spool. One thing I don't really like about the Raspberry Pi single board computer is that you are limited by supply chain and you can't design your own circuit board form factor, but now that they're starting to make their own microcontrollers, you can design your own circuit board and you can get that same chip and it's cheap and it comes on a spool and you can stick it in the pick and place machine and you can...
So I think where the Raspberry Pi sees that.
Well, it's funny because you were talking last night about how you still, your parents still ask like, what do you actually do? And the answer that you gave them was, we make computers. We make computers, but in different shapes. And we're kind of getting to the point now where computing power is really cheap and comes in really small packages. And the only question is, what shape do you want to make the computer? Because as humans, you know, we're constrained by our shape. We have 10 fingers and 10 toes, and we have to interact with things. And so, but the computers themselves are so small, we can think about designing what shape do we want to put the computer in so we can use it to do what we want.
And I think for this last few years, we have a very strong push, new drive to that is AI. Before we do Arduino, we can do everything. We have IoT, but for what? Now AI is giving people more meanings, and you need to run AI in a different form factor of computers, and that's happening. So I think we will be it will be, I say, important and versatile to talk more about manufacturing. And I'm so happy you got back to Shenzhen.
Yeah.
And we'll come back more. Maybe we can, not limited to our factory, but we want to help more people to understand about the manufacturing so you can design according to it and to build with the ecosystem. Either it's centralized or decentralized. And also, we have question here. If you want to have a personal tour to our manufacturer, we cannot arrange that every day. But we have Make a Fair in November 16th. And we are going to have 16th. A high tour again. So we want to show everything we know about Shenzhen, about our own manufacturer. So please stay tuned and check out Make a Fair Shenzhen 2024.
There's going to be a tour as part of Make a Fair Shenzhen.
Every year we have a tour, but every year we want to make the tour more useful and more deeper into the real ecosystems. This is one thing. And what else do we have today? I think the time is almost up. If you have more questions, please leave in the comments. Yeah. And thank you, David, so much for joining us. And great thank you for other David and the parents. And hopefully it's still a very fun journey.
Yeah. We'll see what happens 10 years from now.
Yeah, I think we did the last video 9 years ago. Yeah. Maybe after this we will do many videos, and after 9 years later we surely do something. We'll have longer beards. Yeah, I will have that too, to realize something we talked about today, about what's possible for the future. Yeah. Cool. Thank you so much for joining us. Thank you so much.
See you in the future.
See you in the future. Bye-bye.
Bye-bye.